going to be dealing with calculus today, and this is one of my favorite topics, and we're going to see why. So calculus is a branch of mathematics that includes differentiation and integration. So the derivative of y with respect to x is denoted by dy by dx, which is of course read as the derivative of y with respect to x, or dy by dx. So when we'll be talking about derivative, we're in essence talking about dy by dx, we're in essence talking about differentiating. Okay, so it's the same one. So if somebody told you to get the derivative of a certain function, it's the same as getting dy by dx, as you can see here, and it's the same as saying differentiate this function. What do we mean by all this? We've given it a number of words. So what we mean is this. For example, assuming you have a straight line. So I want to assume I have a straight line. This is a graph first, like this. And in this graph, I want to have a straight line first. Just excuse me a bit. Yes, so let's assume this is a straight line. So if you want to find the gradient of this line, or the change in y with respect to x, so this is the x-axis, this is the y-axis, right? So you want to see how much is y changing with respect to x. So you're looking at the change in this y with respect to change in x. So if it's a straight line like this one, the gradient at any part of this line is actually the same. So let's assume you're having a lorry climbing this slope here. So you have a car here, it's climbing on this slope. So you can see this car throughout the line, the slope is the same. So the gradient again is the same as the slope. Okay, so gradient is the same as slope. And so we are saying if it's a straight line, the change in y, because this is the change in y, this is the change in x. Okay, so the change, finding the gradient or the slope, let me actually just put it very clear there. Gradient or the slope, how do you find it for a straight line? It's equals to the change in y divided by the change in x. So that's for a straight line. So how about if it was a curve? And you have to know that the gradient at any point of a straight line is the same. So when you're dealing with straight lines, the gradient at any point on the straight line is the same. So whether the car is at that point, or even at this point, or even at this point, the gradient or the slope remains the same. Okay, so now that is different when you're referring or talking about a curve. Okay, that's different. So for now, let's say this point here is this is 4, and this point here is 6, and then this point here on the y-axis, this again is 4, and this point here is, say, this is again 6. So if you're told to get the gradient of that line or the slope of that line, what do? You do change in y. So change in y is this 6 minus this 4. So 6 minus 4 divided by 6 minus 4 again for the x-axis. So again 6 minus 4. So you're going to get here 2 divided by 2, which is 1. So the gradient of this line is actually 1. Okay, so having said that, now this is the gradient of a straight line. Now I would just want you to get the difference between the straight line and the curved line. This is just an introduction of the calculus. Now let's go now to a curve, because now a curve is different. And why is it different? Because at any point of the curve, the slope or the gradient is actually changing at any point. Okay, at any point it's changing. So let me just give me a minute. I draw the curve here. So assuming you have this curve right there, so the gradient at any point on the curve changes at any point. So the gradient at this point is different from the gradient at this point. It's different from the gradient here. It's different from the gradient here. Why? Because the curve is changing instantaneously because of the change of direction. So again, if I was to draw a curve here, the gradient or the slope will look like this. If I draw it here, it's going to look like this. You can see the slope has reduced. If I draw it here, it's actually almost flat. If I draw here, again, it's bending on the other direction. Okay, so you can see the gradient at any point. Okay, so I'm assuming this is a car. When the car is at this point, you can see it's very slopey. When the car is at this point, the slope has reduced. When the car is at the top here, there is no slope, it's actually flat. And it's here, the gradient has again changed direction. And now this is a negative gradient. This is a positive gradient. Okay, so you can see the gradient is changing at any point on the curve. So we cannot say change in y over change in x because it changes at every point. So what do we do? Now that's how we employ the derivatives or we differentiate. Okay, so to differentiate, we have different rules, okay, or properties to actually help us differentiate or get the derivatives. So the derivatives should not scare you. It's just the same as differentiating, it's the same as getting the gradient over slope. So in this case, I'm assuming, now let's assume this, let me just remove this. This is just to show you what we mean. Okay, so we want to now get the gradient of a certain function. So what do we do? So again, what is the purpose or the significance of derivatives? It is getting the gradient on a curve. Okay, so if you want to get a gradient at this point, let's assume this point is 4. So this is where x is equals to 4. So it says here. So you want to get the gradient at that point. So how do you get the gradient at this point on the curve? Okay, you do what? You get the derivative, or you differentiate the curve now and you get the gradient at 4. So let's assume this curve is y is equals to 3 or just x cubed. Just put x cubed. X cubed, that is your curve. So this curve here is y is equals to x cubed, and you want to get the slope or the derivative or the gradient of the curve at that point. So how do you get that? Okay, how do you get that? So the general formula is y is equals to xn. In this case, this y is equals to xn here. In this case, x is of course the independent variable, y is the dependent variable, and n is the power with which x is raised to. Okay, so when we write y is equals to x to power n, so what you're saying is this y is the dependent variable. Why is it dependent? Every change in x affects the change, affects the change in y. And why is this one called the independent variable? Because it does not, it's the one that affects y. Y does not affect x. Okay, so x is independent. Then of course n, our n here is the power with which x is raised to. So how do we get the derivative of that? And remember when we were introducing, we said that a derivative, or to get the derivative of a certain function which is denoted as dy by dx, is given by n, x which is our independent variable, n minus 1. So if we are just taking this n right here and taking it here, then x n minus 1. So this is the general formula. Okay, the general formula, this one here, of actually getting the derivative. So now let's do an example with this formula and see. So what if you're given now our equation right here? So I'm going to take this equation. So this is the equation I want to work out. So I do y is equals to x cubed. Alright, so what is our dy by dx, which is a change of y with respect to x? So how do we get that? You take your n, we know that our n there is actually this 3. So you take 3 using our formula, then x, then n is 3, so 3 minus 1. Okay, so that's how you do that. So of course you have to simplify that, so you're going to do this will be equal to 3x, 3 minus 1 is 2, so 3x squared. So your dy by dx is 3x squared. Okay, so this is called the power rule, or it's generally the basic rule. So we've now done an example with that. So we have different types of equations, and these equations come like this. For example, we have one equation that can be y is equals to 3x to the power 4. So what is this 3? This 3 is the coefficient of x. This 4 is the power of x. Okay, then you also have an equation like this: y is equals to x cubed. Now you realize that now x does not have a coefficient, or you can even as well as say x has the coefficient being 1. Okay, so assuming it doesn't have a coefficient, so it's just x cubed. So what is the general formula of getting the derivatives? This is the general formula for getting this kind of derivative, or that kind of equation. Now how about the top one? So for this top one, the general formula, so dy by dx is given by a n x n minus 1. So you can see we have introduced an a here. So what is that a? That a is this coefficient right here, 3. So we said 3 is the coefficient of x. So this a here, right here, is this 3 here. So in short, we multiply the coefficient by n, then x, then n minus 1. So the same here. So we are going to take 3 times 4, which is a times n, then x, 4 minus 1. So in short, to get the derivative of our first equation right there, we have to get the derivative of our first equation, and our first equation is this one. So what is our dy by dx? You get it by doing what? Now a times n. So 12, 3 times 4, which is 12. Then x, n minus 1. So n minus 1. So 4 minus 1. So in short, you're going to get 12x to power 4 minus 1 is 3 to power 3. So that's the derivative of our first equation. Now, how about our second equation? Probably by now you can also be doing it ahead of me. So we want now our second equation, which is this one. So how do we get the derivative? Dy by dx will be given by, this is our formula, so n, which is 3. We are using this formula, remember? So 3x, then 3 minus 1, which is n minus 1. So this will be 3x to power 2. So this becomes the derivative of this equation right here. Okay, so that is called the power rule. So there is also another rule for differentiating. Remember we said we have different kinds of equations. So the next one is called the sum rule. So in short, you have two equations having two different equations inside the same equation. So for example, you can see we have the general formula here, or the general equation, and then the formula of how to get the derivative. So I'll give just an example. For example, you have y is equals to 3x squared plus 4x cubed, and you told get the derivative of this equation, or differentiate this equation. So what would you do? So dy by dx of this equation would be, remember our rule, so this would be, remember our rule is a n x n minus 1. So that's what I'm going to apply here. So our a is 3, our n is 2. So an is 3 times 2, which is 6. So 6x, then 2 minus 1, which is 1. So because any number raised to 1 is still that number. For example, if you raise 10 to power 1, this is still 10. Okay, so x raised to power 1 is still x. So there's no need of putting this one right here. So then plus, now here you're just adding. So you're going to do now, remember we're still back to our formula again. So our a is 4, our n is 3. So 4 times 3, 12, then 12x, then 3 minus 1, which is 2. So here you're going to write 2. Okay, so you'll have 12x squared. So this becomes the derivative of this function there. So that's ideally, that's the sum rule. So you differentiate each part separately and add this addition sign at the middle just as it is. So that's the sum rule. Again, we can do one more example. Just one more example. So if we say y is equals to 5x plus 3x squared plus 4x cubed, and you told now get the derivative of that function. So ideally you differentiate each part of that equation separately, and of course add the signs in between. So now dy by dx, so dy by dx will be given by, so remember we are still using our general formula here. This will be given by what is our n on the first portion. So what is our n on this portion here? Our n is actually 1. So anytime you see x being alone, just know that your n is actually 1. Okay, because remember we said any number raised to power 1, so 4 raised to power 1, this is also 4. So if you want to write 4, in other words, you can just write it as 4 to power 1. So anytime you see a number like x or a letter like x and doesn't have a power raised to it, just know automatically that that's power 1. Okay, so now when you are differentiating, our n in that first part is 1. So 1 times 5, remember we are still using this formula, so a times n. So 1 times 5 is still 5. Then x, 1 minus 1. So 1 minus 1 is what? 1 minus 1 is 0. Okay, so x raised to power 0 right here. Okay, what is any number raised to power 0? So any number raised to power 0, so 4 to power 0 is equals to what? 1. Y to power 0 is 1. 100 to power 0 is 1. So any number raised to 0 is 1. Okay, I hope that is very clear because that's very critical for you to understand. Any number raised to power 1 is 0. So 5 times x raised to power 0 is 5 times 1. So we are going to handle that later. Then plus 3 times 2, which is 6. Then x, 2 minus 1. So 2 minus 1. Plus 4 times 3, which is 12. So 12x, 3 minus 1. Okay, so you're going to get here 5 times 2. Remember we said the x power 0 is 1, so 5 times 1 plus, then 6, 2 minus 1 is 1. So we said any number raised to power 1 is what? Is the same number. So x raised to power 1, because 2 minus 1 is 1. So when you say 6x to power 1 is the same as 6x. Okay, so we don't need this one here. Then plus 12x, 3 minus 1 is 2. So ideally you're going to have your answer being 5 plus 6x plus 12x squared. So this becomes your dy by dx of this function right here. So I hope that has sunk in very well. So now I'll still do one more example. One more example here. So what if you have now y is equals to 4x minus 5x squared plus 2x cubed, and you're told now divided by 8 and you're told now get the derivative of that function. Now this is actually not hard. So if you have such a function, the first thing is first simplify it. So how do you simplify? If you have 8 at the denominator, remember 8 is the denominator for all those portions of for this part, for this part, for this part. So 8 is the denominator. So the first thing you do, write it in a simpler form, is, so you can also say y can also be 4 over 8x minus 5 over 8x squared plus 2 over 8x cubed. So how did we get that? So assuming you have an equation like 10 over 2 plus, no, let me put it this way. You have an equation like 10 plus 8 plus 6 over 2. So this can also be written as 10 over 2 plus 8 over 2 plus 6 over 2. You can check that with your calculator, you get the same answer. So that's what we have just done in this equation. Now we have simplified to that side because we have done that to make it easy for us to differentiate. So now once we have done that, now we have our a, we have our n. So in the first part, which is our first part, this is the first part. In the first part, what is your a? Your a is 4 over 8, your n is 1. So now going back to our formula here, your a, so a times n is 4 over 8 times 1, which now remember now we are getting dy by dx. Okay, so 4 over 8 times 1 is 4 over 8, then x, remember we have 1 there, 1 minus 1, then minus 5 over 8 times 2, because our a on our second part here, now we are at this point, our a is 5 over 8, our n is 2, so 5 over 8 times 2, then x 2 minus 1, then plus our a is 2 over 8, our n is 3, so again 2 over 8 multiplied by 3, which is our n, then x 3 minus 1. Okay, now having that, now you can simplify it now further. So this will now be 4 over 8, which is of course when you do by 4, 1, so this will be a half, 1 over 2, then x 1 minus 1 is 0. And remember we said when you raise any number to 0, it becomes 1. So instead of writing half x to the power 0, it's half times 1, which is still a half. Okay, so we don't need to write that. So minus, so a half minus. Okay, now when we come here, 5 over 8 times 2, which is now 10 over 8. Right? Then 10 over 8 now x 2 minus 1, which is 1. So I say there's no need of writing that one because any number raised to power 1 is still that number. So you can actually cancel that. Then you go to we are done with the second part. Now you go to the last part. Now plus, now we are right here. Remember? So 2 over 8 times 3, which is 6 over 8. So 6 over 8x, then 3 minus 1, which is 2. Okay, so you can now of course simplify further. So you'll have now a half, you can simplify a half, then 10 over 8, which is 5 over 4, okay, x, then 3 over 8 is, 6 over 8 is, when you simplify that will be 3 over 4, then x squared. So now this is our dy by dx. Okay, this is our dy by dx, as you can see there, right? So that's our dy by dx, as you can see it there. Okay, now in the next one you're going to be looking at, now that was the sum rule. Now we're going to be looking at now other ways of finding the derivatives. So see you in the next class.